How's it going, everyone? We're going to open up our Jupyter notebook. So here, since I've already created my own Jupyter project, I just click to this Jupyter notebook here, and this will bring me to the home page. And I'll just come to this project directory, and boom, I just create all the notebooks and upload all the data set that I need. So for you, you can upload your own data set or upload your own Jupyter notebook here and run on the cloud at scale, which is cool. But as this is the first time we're here, we're just going to create a new notebook here, which is the PDA for us to analyze the e-commerce data. And since this is a demo video, I'm going to show you some of the predefined code to show you how you can run the Python code on the desk cluster. So let's open this notebook here. Now we have the notebook ready. Before you can use the cluster, you need to call the client and define your cluster. So here you're going to bring your scheduler URL, which you can find on your desktop. So you come back here on your dashboard, go to this scheduler URL and copy this line here, admin, all the way to here. And you copy this and paste it over here, which is your scheduled URL, and this will spin off your cluster immediately and you can use it right after. Okay, so I will run this, and they're located to 10 workers with 10 CPU cores. About quite a bit of memory because of the specification that I selected earlier. So here you can just do whatever you want. It's basically the same thing that you usually do in your own Jupyter notebook. Nothing changed. We just followed back what we're used to. So we import all the Python libraries here. And we just read the Dask data frame right to a variable here. So here I'm getting the data from the Amazon S3, of course. You can also upload your data set to your directory here, and you can call it as well. So it's up to you. You can call it from Amazon S3, call it from your directory here, or query from other HDFS files. Whatever it is that you want to call here. So here I specified the block size to be 32 megabytes. So at the end of the day, it's really up to you to define how big you want your partition. You can define the partition to be bigger, to be smaller, so it's definitely up to you. So maybe one CSV file, you want it to be one partition. So here, since I just loaded one CSV file, I purposely split it into two different partitions to show you how this partition works on the back end. We already defined this Dask data frame. If you just come and grant this df, typically on the Python Dask data frame, if you just run the df, you show us all the data sets in data frame. Here in that Dask data frame, it's slightly different. It still shows you the data frame structure in Dask, but it will show you just the column name, partition number, two partitions here, and how many tasks you can run concurrently. In fact, your dataset is not loaded in memory yet. They just try to infer the data type in your data frame. Here you can see that each of the columns that are caught that have object, 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 integer, integer, float, etc. That's why Dask can run so efficiently and so fast, because they haven't done anything unless you execute the method, which is the compute method, which I'll explain later on. So here finally, if you just click this dot here, it'll show you the top 5, as usual, the data set for top 5 rows of your data sets. But since you have really understood that Dask data frame, most of their interfaces, they provide lead results, which means it is essentially a graph. If you are familiar with TensorFlow or these essentially, they are building a computational graph and they don't execute unless you call a method to trigger the execution. So here in the Dask data frame, it hasn't really loaded any memory yet. It just shows you the object, data type, etc. So here, even if you just want to calculate the average value of the unit price here, if I just dot mean, which is what we typically do in our Dask data frame, it'll just show us a series without any computation. This is not what we want. Here, if you want to get the true result, you need to run this df unitprice.mean.compute. So what you need to add is just the compute method. That's it. So this will trigger the whole execution, the whole graph, the whole computation, workflow operation that you defined earlier. They're predefined here, which is the dot mean. This is how we really execute an operation, in general using Dask data frame. Even if you want to find out the shape here of the data frame, you need to use a compute, etc. Value counts. So you can see all the things that are essentially quite similar, essentially very similar to what we used to do using Pandas data frame, which is cool. Because this is what we want. We don't need to learn an entirely new different syntax or language just to run things in parallel, which is very effective and time-saving for data scientists. So here again, you can see each of the partitions here. Like you already know, each of the partitions is essentially a Pandas data frame. So imagine right now our Dask data frame has two partitions. Each of the partitions here is one Pandas data frame. So if you choose one of the partitions here and make the computation, you're essentially showing these particular partitions. And this is in the Pandas data frame format, which is cool. Because maybe you want to do some operation or transformation for this partition, you can just load it to a new variable. And you can do whatever you want, like what we used to do in Pandas data frame. Also, you can rename the column names, like what we do on our Pandas data frame. Or the things here can do data cleaning, or the previous code that you saw in the article, the things that I just shared with you guys, and some of the missing values calculation. And you can even change the data time. This is the syntax here. The method used here is exactly the same as how we work in Pandas data frame. Or maybe sometimes you want to find the data set based on certain conditions, so you can do the same thing as well.